August 14, 1943, Ypsilanti, Michigan. A convoy of olive-drab military buses rolled through the gates of Ford Motor Company's Willow Run manufacturing complex, carrying 47 German prisoners of war. Among them sat Oberst Heinrich Baumer, a 52-year-old Luftwaffe engineering officer who had spent 23 years designing aircraft production facilities across Germany. He had been captured 3 months earlier in Tunisia, still wearing the Iron Cross he'd earned in the First War. His hands bore the calluses of a man who had worked metal, drawn blueprints, and built the factories that armed the Reich's Air Force. As the bus turned down a service road, Baumer pressed his face against the window. What he saw made him forget to breathe. A building. One single building. Stretching across the Michigan countryside like a steel horizon. 3.5 million square feet under one roof. So massive that clouds formed inside on humid days. So long that supervisors used bicycles to traverse its length. The largest room ever built by human hands. Baumer had designed the Messerschmitt factory at Regensburg, the pride of German aviation engineering. It covered 240,000 square feet. Willow Run was 14 times larger. He turned to the young lieutenant beside him, a fighter pilot shot down over Sicily. The boy was 23, still healing from burns. "Do you see that building?" Baumer whispered in German, his voice hollow. "Ja, Herr Oberst. Germany has already lost the war. We just don't know it yet." The transformation from skepticism to industrial annihilation began not in 1943, but 4 years earlier, in a conversation that would reshape modern warfare. The date was January 16, 1939. The location, Henry Ford's private office in Dearborn, Michigan. William Knudsen, president of General Motors and a former Ford production chief, had returned to visit his old mentor. The two men, both sons of European immigrants, stood at a window overlooking the Rouge River plant, watching molten iron pour into molds that would become engine blocks for Ford automobiles. Henry Knudsen said, "If war comes to Europe, they're going to need aircraft, tens of thousands of them." Ford, 75 years old and still commanding, turned from the window. "Europe has aircraft factories, not like what we could build." Ford's response was immediate and dismissive. "We build cars, Bill. Cars have 4 wheels and stay on the ground. Airplanes are custom machines. You can't mass-produce airplanes like you mass-produce automobiles. Every aviation expert in the world will tell you that." Knudsen smiled. It was the same smile he had worn in 1913 when Ford told him you couldn't build a moving assembly line for automobiles. Every expert said we couldn't build 15 million Model Ts either. We proved them wrong by refusing to accept their limitations. By December 1940, with Britain standing alone against Nazi Germany, the conversation had moved from Ford's office to the United States government. President Franklin Roosevelt announced a goal that staggered aviation experts worldwide. America would build 50,000 aircraft annually. The military establishment responded with polite skepticism. General Henry Hop Arnold, Chief of the Army Air Forces, confided to his staff that 50,000 planes per year was an impossible target, created by politicians who don't understand aircraft production. America's entire aviation industry in 1940 consisted of perhaps a dozen companies scattered across the country. Boeing in Seattle, Douglas in California, Consolidated in San Diego, Martin in Baltimore. These firms employed master craftsmen who hand-fitted components, filed metal until it matched perfectly, and treated each aircraft as a custom creation. In 1940, the entire American aviation industry produced 6,086 military aircraft. The president wanted 8 times that number. Every year, Charles Sorensen, Ford's production chief and the man who had designed the moving assembly line for the Model T, read Roosevelt's announcement and saw something different. He saw a challenge that matched his entire career philosophy. The impossible is just a problem nobody has solved correctly yet. The engineering team that gathered in Dearborn in January 1941 faced a fundamental problem. The military wanted B-2 for Liberator heavy bombers. The B-24 was Consolidated Aircraft's answer to Boeing's B-17 Flying Fortress. It was faster, carried more bombs, and flew farther. It was also monumentally complex. A single B-24 contained 1,550,000 individual parts. It had 360,000 rivets, holding together 27,000 square feet of aluminum skin. The aircraft weighed 65,000 pounds, fully loaded. Its 4 engines developed 4,800 horsepower combined. Its wingspan measured 110 feet, wider than the Wright brothers' first flight was long. Consolidated Aircraft's San Diego plant could build approximately 2 B-24s per day at peak efficiency, requiring 120 days per aircraft from start to finish. Their workers were experienced aviation craftsmen. The factory was purpose-built for aircraft production. Charles Sorensen walked through Consolidated's facility in February 1941, invited to observe their methods. What he saw confirmed his suspicions. Aircraft were being built like ships had been built before Kaiser, one at a time, in fixed positions, with craftsmen moving around the stationary airframe. Workers fitted components individually. Nothing was standardized. If a fuel line didn't quite fit, a craftsman filed it until it did. If a panel sat wrong, they hammered it into place. Each aircraft was unique, requiring constant adjustment and fitting. Sorensen returned to Michigan and told Henry Ford, "They're building airplanes the way we built cars in 1903, one at a time, by hand. We can do better." Ford's response was immediate. "Design a plant that can build 1 bomber per hour." The engineering team stared at him in silence. Consolidated built 2 per day. Ford wanted 12 times that rate. "It's impossible," said the senior aeronautical consultant Ford had hired from Douglas Aircraft. "The B-24 is not a car. You cannot mass-produce complex aircraft." Sorensen stood. "Henry, give me 6 months, an unlimited budget. I'll show you impossible." The land Ford purchased for Willow Run lay 30 miles west of Detroit, near the small town of Ypsilanti. It was 1,700 acres of farmland, flat and empty, perfect for the largest factory building ever conceived. Albert Kahn, America's foremost industrial architect, and the man who had designed Ford's Rouge plant, received the commission in March 1941. The specifications were unlike anything he had encountered in 40 years of designing factories. Building length, 3,200 feet, more than half a mile. Building width, 1,280 feet, nearly a quarter mile. Clear interior height, 36 feet to accommodate bomber tail sections. Total enclosed space, 3.5 million square feet, later expanded to 4.1 million. Kahn's preliminary drawings horrified structural engineers. A building that large couldn't maintain its own integrity. Temperature differentials between one end and the other would cause expansion and contraction that could tear the structure apart. The roof would collapse under snow load. Kahn designed it anyway. The solution required 17,000 tons of structural steel, 24,000 tons of reinforced concrete, and construction techniques borrowed from bridge building. The roof used truss systems normally found in railroad terminals. The foundation reached 40 feet deep to bedrock. Construction began in April 1941. Ford's engineers, the same men who had built the Rouge plant, attacked the project with systematic intensity. At peak construction, 32,000 workers labored around the clock. Concrete was poured continuously for 3 months. Steel erection continued through winter, with welders working in -10-degree temperatures. By March 1942, the main building was complete. The interior was a single vast room, empty and echoing. You could stand at one end and barely see the other through the haze of distance. The building was so large, it created its own weather. On humid days, clouds formed near the ceiling and rain fell inside, requiring drainage systems in the factory floor. William Knudsen, who had left GM to become director of the Office of Production Management, coordinating all American war manufacturing, toured Willow Run in April 1942. He stood in the empty building and later wrote in his private journal, preserved at the National Archives, "I have built automobile factories across America for 30 years. I have seen the Rouge, the largest integrated industrial complex on Earth. But standing inside Willow Run, I felt I was standing inside a different future. This building makes everything I have done look small. If we can make this work, we can build anything. The workers began arriving in May 1942. They came from farms across Michigan, from closed auto plants in Detroit, from Appalachian coal towns, from everywhere unemployment and patriotism could drive them. They came by the thousands. Ford's hiring standards shocked the established aviation industry. Consolidated Aircraft required 3 years of aircraft experience for basic assembly positions. Boeing wanted 5 years for critical stations. Ford hired anyone who could pass a basic dexterity test and committed to training. Margaret Davis arrived at Willow Run on June 3, 1942. She was 34 years old, mother of 2 children, and had worked as a secretary in Detroit before her husband shipped overseas with the 1st Armored Division. She had never touched an aircraft, never held a rivet gun, never read a blueprint. Ford's training program gave her 2 weeks of instruction, not comprehensive aircraft knowledge, specific, limited, repeatable skills. Margaret learned to buck rivets on curved aluminum skin sections. Just that. 8 hours a day for 2 weeks. She practiced driving rivets through sheet aluminum curved to match bomber fuselage specifications. By her 3rd week at Willow Run, Margaret Davis was installing rivets on actual B-24 fuselages, working on a moving assembly line that advanced 42 inches every hour. She would install the same 17 rivets on every bomber that passed her station. She would do it 12 times per shift. She would do it 6 days per week for the next 3 years. By September 1942, Willow Run employed 24,000 workers. Fewer than 400 had any previous aircraft experience. The rest were farmers, housewives, store clerks, and laborers who had learned specific tasks in days or weeks. The aviation industry watched with barely concealed contempt. The president of Curtiss-Wright, one of America's oldest aircraft manufacturers, visited Willow Run in August 1942 and sent a scathing report to the War Production Board. Ford has built a magnificent factory and filled it with untrained labor. They have taken the most complex aircraft in American production and subjected it to assembly line. Techniques that work for simple automobiles but cannot work for sophisticated aircraft. Willow Run will be remembered as an expensive failure and a cautionary tale about automobile men who didn't understand aviation. The criticism intensified. When early production numbers appeared disappointing, Ford had promised 1 bomber per hour. The goal seemed increasingly delusional as Willow Run struggled through summer and fall 1942. In July, they completed 31 bombers. In August, 46. In September, 56. These weren't the numbers that would win wars. Newspapers, frustrated by the gap between Ford's promises and actual production, began calling the facility Willow Run. What critics couldn't see was the learning curve in action. Every day, workers became slightly more efficient. Every week, production systems improved. Every month, bottlenecks were identified and eliminated. The mathematics of mass production began revealing their power in late 1942. Charles Sorensen had organized Willow Run around a principle that violated every convention of aircraft manufacturing. Radical subdivision of labor combined with moving assembly. Traditional aircraft plants built planes in fixed positions. Workers and components moved to the aircraft. At Willow Run, the aircraft moved to the workers and components. The bomber fuselage began at one end of the building as bare metal sections. It traveled down the assembly line, advancing through 3,200 feet of factory floor over several days. At each station, workers added specific components: electrical systems, hydraulic lines, control cables, instruments, armor plating, gun turrets. By the time a fuselage reached the final assembly area, it was 90% complete. Wings built in parallel subassembly areas were lifted by massive overhead cranes and mated to the fuselage in a single operation taking 4 hours. Traditional plants required 3 days for wing installation, with craftsmen fitting and adjusting and filing until everything aligned. Ford's wings were built to tolerances that made fitting automatic. The parts simply matched because engineering had ensured they would match. No craftsman skill required. No adjustment necessary. Just precision manufacturing. The 4 engines arrived from subcontractors already mounted on their nacelles, with all accessories installed. Overhead cranes lifted complete engine assemblies and lowered them onto wing mounting points. 8 men with impact wrenches secured each engine in 45 minutes. Traditional methods required 2 days per engine. By January 1943, Willow Run produced 105 bombers. By February, 155. By March, 196. The curve was accelerating. April 1943, 225 bombers. May, 268. June, 312. July, 352. In August 1943, Willow Run delivered 365 B-24 Liberator bombers to the United States Army Air Forces. More than 11 bombers per day. 1 bomber every 63 minutes of every working hour. The same aviation executives who had predicted failure went silent. This was the Willow Run that Oberst Heinrich Baumer entered on. August 14, 1943. The guards led the German posts into the factory through a side entrance. The noise hit them first. A sound like continuous thunder, the accumulated roar of 24,000 workers. Thousands of power tools, hundreds of engines being tested, metal being cut, rivets being driven, all echoing inside the world's largest room. Then they saw the assembly line. Bombers, dozens of them, stretching away in both directions, farther than the eye could clearly see. But these weren't finished aircraft parked on a field. These were aircraft in every stage of assembly, positioned along a line that moved constantly, inexorably, like a river of aluminum and steel flowing toward completion. Bare fuselage sections at the beginning, nearly complete bombers at the end. And between them, a systematic progression of construction that looked less like aircraft manufacturing and more like some enormous mechanical organism, digesting metal and producing warplanes. The American officer escorting them, a colonel who spoke fluent German, watched their faces. "Gentlemen," he said, in German, "welcome to Willow Run. We build B-24 Liberators here. In August, we will deliver 365 aircraft. That is 1 bomber every 63 minutes, 24 hours per day." One of the younger German prisoners laughed. It was a nervous, disbelieving sound. "This is propaganda. You are showing us a demonstration. This cannot be normal production." The colonel smiled. "Oberst Baumer, you are a manufacturing engineer. Please, walk the line. Examine anything you wish. Tell me if this is propaganda." For the next 3 hours, Baumer walked slowly along the assembly line, stopping at stations, watching workers, examining the systematic organization of tools and components. His trained eye saw things the younger prisoners couldn't comprehend. He saw the subdivision of labor, each worker performing one specific task, repeated on every aircraft. No wasted motion, no decision-making, just practiced, efficient repetition. He saw the prefabrication, subassemblies arriving at the main line already complete, ready for installation. No time spent building components in place. Just systematic integration of pre-built sections. He saw the tooling, custom jigs and fixtures that held components in exact position for joining. No measuring, no adjusting. Parts went into fixtures. Fixtures ensured perfect alignment. Workers joined the parts. Precision through equipment rather than craftsman skill. He saw the moving line. The bombers advanced continuously. Workers didn't move to the work. Work moved to the workers. Each station had exactly the time required for its task. No more, no less. The line speed determined production rate. And he saw the workers. Young women riveting aluminum skin, old men installing electrical systems, former farmers fitting hydraulic lines. None of them craftsmen, all of them efficient. At one station, Baumer stopped beside a woman who was installing control cables through a fuselage section. Her hands moved with practiced speed, threading cables through pre-drilled openings, securing them with clips, testing tension with a simple gauge. "How long have you worked here?" Baumer asked in English. The woman looked up, surprised. 5 months, sir, before the war. What did you do? I taught 3rd grade, elementary school, and they taught you to install aircraft control systems in 5 months. The woman smiled. No, sir. They taught me to install these 16 control cables in this specific configuration. That's all I do. 16 cables, same position, every bomber. I do it 12 times per shift. After 5 months, I could do it blindfolded. Baumer walked back to where the colonel waited. The German officer's face had gone pale. His hands trembled slightly. This is real, Baumer said quietly in German. This is actual production. Yes, every day. Every day. How many of these facilities does America have? The colonel's smile was grim. We are building B-24s at Willow Run, Consolidated San Diego, Consolidated Fort Worth, Douglas Tulsa, and North American Dallas. We are building B-17s at Boeing Seattle, Douglas Long Beach, and Vega Burbank. We are building medium bombers at 7 additional facilities. We are building fighters at 15 factories. We are building transport aircraft at 8 plants. Baumer did the mathematics in his head. The numbers were staggering. Impossible, but he had just walked through the proof that impossible was a word that no longer applied to American manufacturing. Germany is building approximately 40,000 aircraft per year across all types, Baumer said. Total production for the entire Reich. Yes, we know. We have excellent intelligence. How many will America build this year? Our current projection for 1943 is 96,000 aircraft. Next year, we expect to exceed 120,000. The silence that followed was broken only by the distant thunder of production. Baumer stood very still, processing information that destroyed his understanding of what was possible. We cannot win, he finally said. The mathematics make victory impossible. The American colonel nodded. Yes, but your generals haven't learned that yet, so the war continues. The bus ride back to the POW camp at Fort Custer was silent. The German prisoners stared out windows, each man processing what he had seen. The young lieutenant finally spoke. Herr Oberst, what we saw, that cannot be real, it must be a trick. They are trying to demoralize us. Baumer turned to look at the young pilot. I wish it were a trick. I have designed aircraft factories in Germany for 23 years. What we saw today is real. Worse, it is efficient. Ford has done to aircraft what he did to automobiles 30 years ago. He has made them a mass production commodity. But Germany has the best engineers, the best designers. Germany has excellent engineers, designing excellent aircraft, Baumer interrupted. America has adequate engineers, designing adequate aircraft in quantities that make excellence irrelevant. One excellent fighter facing 10 adequate fighters still loses. Another prisoner, an older Hauptmann who had commanded a bomber group, spoke carefully. Should we tell the others in the camp? Baumer considered this. Yes. They deserve to know the truth. Germany is fighting a war against arithmetic. We cannot win through valor or tactics or superior technology. America can replace losses faster than we can inflict them. We are trying to empty the ocean with a bucket. The report that Baumer wrote that evening, which he managed to pass to American intelligence officers through camp channels, was later declassified in 1973. It sits now in the National Archives, a remarkable document written in precise German, translated by American analysts. The relevant section reads, I was taken today to Ford's Willow Run facility. What I witnessed there has convinced me that German victory is mathematically impossible. The Americans have industrialized warfare in a manner that makes traditional military excellence obsolete. They are building bombers the way they build automobiles, using unskilled labor, moving assembly lines, and prefabrication techniques that achieve production rates incomprehensible to German industry. Germany's entire aircraft industry employs approximately 1.9 million workers to produce 40,000 aircraft annually. This single American factory employs 24,000 workers and will produce 4,400 bombers this year. The productivity difference is staggering. American workers at Willow Run are producing aircraft at 8 times the rate of German workers. More critically, their methods are scalable. They are training workers in weeks where we require years. They are building new factories in months where we require years. They are designing production systems that make skilled craftsmen unnecessary. I respectfully suggest that intelligence officers thoroughly investigate American industrial capacity. What I saw today suggests that our estimates of American production are dramatically low. If Willow Run is representative of American industrial philosophy, and if they are applying these techniques across all war material production, then Germany faces an opponent whose industrial capacity may exceed our own by an order of magnitude. Traditional military strategy cannot overcome such disparity. We are fighting the wrong war with the wrong assumptions. The strategic implications of Willow Run and facilities like it became clear as 1943 progressed into 1944. American aircraft production reached levels that fundamentally altered the balance of power. In 1943, the United States produced 85,898 military aircraft of all types. Germany produced 24,807. The United States outbuilt Germany 3.5 to 1. In 1944, American production reached 96,318 aircraft. German production, despite mobilization of all available resources, reached 39,807. The gap had widened to 2.4 to 1, but only because Germany had sacrificed everything else to aircraft production. Willow Run alone produced 4,476 B-2 for bombers in 1944. That was more for engine-heavy bombers than Germany's entire aviation industry produced across all aircraft types. The mathematics of attrition became clear in the strategic bombing campaign. In 1944, the 8th Air Force lost 1,623 bombers over Europe to all causes. This was catastrophic by any traditional measure. But American factories were producing 16,000 heavy bombers that same year. Losses could be replaced in 5 weeks. The Luftwaffe destroyed bombers at a rate of approximately 4% per mission. But America was building bombers at a rate that made 4% losses sustainable indefinitely. Germany was fighting an opponent who could absorb losses that would cripple any traditional military force. Luftwaffe pilots understood this reality before their commanders. They shot down bombers by the dozens, then returned to base to find their airfields being bombed by hundreds more. They destroyed fighters in combat, then faced fresh fighters the next day, while their own losses could not be replaced. General Adolf Galland, commander of Luftwaffe fighter forces, wrote in his post-war memoir, "By 1944, we knew we were fighting a losing battle. We could shoot down American bombers, but they came back the next day with more. We could destroy their fighters, but they appeared in greater numbers. We learned that industrial capacity, not pilot skill, determined the outcome of air warfare. The Americans were not better pilots. They were simply endless." The human cost of Willow Run's production miracle was measured not in casualties, but in exhaustion, displacement, and social upheaval. Building 8,685 bombers in 42 months required sacrifice from workers that history has largely forgotten. The city of Ypsilanti, population 12,000 in 1940, was overwhelmed by 40,000 new workers arriving to staff Willow Run. Housing didn't exist. Workers slept in cars, in boarding houses with 3 shifts, sharing the same bed you rented it for 8 hours. Then the next shift took it, in tents and trailers and converted barns. Ford built temporary housing developments, entire neighborhoods of prefabricated homes erected in weeks. Willow Run Village housed 14,000 workers in 2,500 units. The construction was minimal. Walls were thin. Privacy was non-existent, but they had roofs and beds. Transportation became another crisis. Willow Run was located 30 miles from Detroit, deliberately placed far from urban areas to provide room for expansion. Workers needed to reach the factory for 3 shifts, 6 a.m. to 2 p.m., 2 p.m. to 10 p.m., 10 p.m. to 6 a.m. At peak production, 42,000 workers flooded into Willow Run daily. The roads couldn't handle the traffic. Workers spent 2 hours commuting for 80-hour shifts. Ford organized bus services, running hundreds of buses in continuous loops. The Michigan Central Railroad added special worker trains. Inside the factory, the conditions ranged from uncomfortable to dangerous. The building was too large to heat effectively in winter. Workers near the loading docks froze, while workers near the engine test cells sweltered. In summer, temperatures inside the building reached 110 degrees. Workers collapsed from heat exhaustion regularly. The noise was overwhelming. Constant, pounding, mechanical thunder that left ears ringing after every shift. Workers shouted to communicate 6 inches apart. Many developed permanent hearing damage. The work was repetitive to the point of psychological strain. Installing the same rivets in the same location 12 times per shift, 6 days per week, for months or years, drove some workers to break down. Ford's medical staff documented cases of workers who simply stopped functioning, overwhelmed by monotony. Yet they continued, because the war demanded it. Because their husbands and sons and brothers were overseas. Because the paychecks were good. Because management reminded them constantly that every bomber they built would protect American troops. Margaret Davis, the former teacher who installed control cables, worked at Willow Run for 38 months. Her husband was killed at Anzio in January 1944. She continued working through her grief because she later said, "Every bomber I finished was one more weapon to use against the people who killed him." The statistics of workforce demographics at Willow Run reveal social change that extended far beyond war production. By late 1944, women comprised 32% of Willow Run's workforce. Not secretaries or cafeteria workers, but riveters and welders and hydraulic specialists and electrical technicians. Rose Will Monroe, who worked as a riveter at Willow Run, became the model for Rosie the Riveter. Propaganda posters after actor Walter Pidgeon filmed her for a War Bond Drive promotional film. Her image, captured drilling rivets into a B-24 fuselage, became the iconic symbol of women's wartime industrial contribution. African American workers at Willow Run numbered over 6,000 by 1944, working in positions ranging from basic assembly to skilled trades. This was remarkable for 1940s America, though housing segregation and social discrimination remained endemic. Black workers were restricted to separate housing sections and faced resistance from white workers. The UAW union local at Willow Run fought against discrimination with mixed success. They achieved equal pay for equal work, a significant victory. But they couldn't force integrated housing or eliminate social tensions. Wildcat strikes over integration of facilities disrupted production several times in 1943. The end came with shocking suddenness. On August 14, 1945, Japan announced surrender. Within hours, the War Production Board cancelled all outstanding aircraft contracts. Willow Run's production line, which had operated continuously for 3 years, stopped mid-shift. Workers were informed via loudspeaker, "The war is over. Production has ceased. Report to your supervisors for separation procedures." By September 1945, Willow Run's workforce had fallen from 42,000 to 4,000. By December, fewer than 1,000 remained, mostly security and maintenance staff. The massive factory that had produced 8,685 bombers stood largely empty. The final B-24 built at Willow Run rolled off the line on June 28, 1945. It was bomber number 8,685. Workers signed their names across its aluminum skin. Many cried. They had spent years building machines of war. Now, their war was over. The statistics of Willow Run's production tell a story of industrial achievement that remains impressive 8 decades later. Total B-2 for Liberators produced 8,685. Average production time per aircraft, 1944 to 1945, 110 hours. Fastest single bomber production, 63 minutes from line start to complete aircraft. Total workers employed peak, 42,000. Total worker hours, approximately 40.2 million. Average cost per bomber, 1944, $297,627. Total program cost, approximately $2.6 billion in $1,945. Weight of aluminum used, approximately 1.2 billion pounds. Miles of wiring installed, approximately 104 million miles. Rivets driven, approximately 13.5 billion. Engines installed, 34,740. These numbers, impressive as they stand, become staggering when compared to traditional aircraft production. Boeing's Seattle plant, using conventional methods, produced 6,981 B-17 bombers between 1941 and 1945. This was considered remarkable achievement. Willow Run produced 24%. More aircraft in the same time frame using methods that traditional aircraft engineers had declared impossible. The battle effectiveness of B-24s built at Willow Run matched or exceeded aircraft built by experienced aviation companies. Loss rates were identical across manufacturers. Mechanical reliability was comparable. Mission completion rates showed no significant difference between Willow Run B-24s and those built by Consolidated's expert craftsmen. This was the ultimate validation of Ford's approach. They raised $8 million and saved approximately 144,000 square feet of the original building. The rest was demolished to make room for a parts supplier facility. Today, visitors can tour the preserved section. They can stand in the space where B-24 bombers were assembled. They can see displays of tools and components. They can read the stories of workers who built aircraft that helped win a war. But the building is silent now. Adequate solutions produced in vast quantities defeat perfect solutions produced in limited numbers. The Americans understood this in 1941. We learned it in 1945. That 4-year gap cost us everything. Baumer died in 1968. His obituary in the Frankfurter Allgemeine Zeitung mentioned his wartime work, but not his memoir. Germany preferred not to remember lessons learned in defeat. Mass production using unskilled labor trained in weeks produced aircraft that performed identically to aircraft built by craftsmen trained for years. Quality came from engineering and tooling, and systematic processes, not from worker skill. The post-war fate of Willow Run revealed American pragmatism about industrial facilities. The factory was too large, too specialized, and too expensive to maintain. Ford tried to find buyers. The government tried to repurpose it. Nothing worked. In 1947, Kaiser Frazer Corporation, Henry Kaiser's post-war automobile venture, purchased Willow Run for $1. The price reflected reality. The building was worth less than the cost of demolishing it. Kaiser Frazer built automobiles at Willow Run from 1947 to 1953, never successfully. The factory was designed for aircraft assembly, not automobile production. The company failed in 1953, unable to compete with established automakers. General Motors purchased the facility in 1953 and used portions of it for transmission manufacturing. The massive building was subdivided into separate facilities. The original assembly line disappeared under walls and partitions. By the 1990s, Willow Run had been largely abandoned. Parts of the building were leased to various small manufacturers. Much of it stood empty, windows broken, roof leaking, a decaying monument to wartime achievement. In 2013, the Yankee Air Museum launched a campaign to preserve a portion of Willow Run as a historic site. The thunder of production, the roar of 42,000 workers. The systematic rhythm of assembly line manufacturing has faded into history. Heinrich Baumer survived the war. He returned to Germany in 1946, one of millions of POWs repatriated to a destroyed nation. He worked in reconstruction, helping rebuild German industry under occupation. In 1951, Baumer published a memoir titled Engineering Defeat: How Germany Lost the War of Production. The book received little attention in Germany, where people wanted to forget the war, but found modest success in America and Britain. The relevant passage, translated from German, reflects on his August 1943 visit to Willow Run. I spent 23 years as an aeronautical engineer, convinced that excellence in design and craftsmanship determined the outcome of industrial competition. I believed that German engineering, German precision, German quality were advantages that made us superior to opponents who built adequate products with mass production techniques. Willow Run destroyed that belief in 3 hours. I saw adequate aircraft built by untrained workers, using systematic processes that made excellence unnecessary. I saw quantity achieving what quality could not. I saw the future of manufacturing and understood that Germany was trapped in the past. The lesson was strategic, not technical. Wars are won by nations who can sustain production longer than enemies can sustain destruction. Germany built beautiful aircraft that we could not replace. America built adequate aircraft that they replaced faster than we could destroy them. The mathematics determined the outcome before the first shot was fired. If I could speak to German engineers today, I would tell them, excellence is meaningless at insufficient scale. The legacy of Willow Run extends far beyond the 8,685 bombers it produced. The facility demonstrated principles that transformed global manufacturing for the remainder of the 20th century and into the 21st. The subdivision of labor into repeated specific tasks, rather than comprehensive skills, became standard practice across industries. Modern electronics, manufacturing, pharmaceutical production, and automobile assembly all use variants of the techniques Ford pioneered at Willow Run. The emphasis on engineering for production, rather than engineering for excellence, changed how products were designed. Modern manufacturing considers ease of assembly from the first design sketch. Components are designed to fit precisely without adjustment. Tolerances are specified to eliminate skilled craftsman input. The training philosophy that you can teach specific skills in weeks, rather than comprehensive knowledge in years, revolutionized industrial workforce development. Modern factories train workers for specific stations in days or weeks. The apprenticeship model requiring years of training survives only in small-scale custom manufacturing. The physical layout of Willow Run, with moving assembly lines and parallel subassembly feeding the main line, became the standard factory architecture worldwide. Every modern automobile plant, electronics factory, and appliance manufacturer uses organizational principles demonstrated at Willow Run. Perhaps most significantly, Willow Run proved that industrial capacity could be created rapidly when necessity demanded. America entered World War II with minimal aircraft production capability. Within 18 months, American industry was producing aircraft at rates that exceeded the rest of the world combined. This lesson influenced Cold War strategy, space program development, and modern defense planning. The assumption that existing capacity limits future production was replaced by understanding that capacity itself could be expanded. Rapidly, Dr. Michael Porter, professor at Harvard Business School, analyzed Willow Run in a 1985 study of American industrial competitiveness. Willow Run represents one of the most important case studies in manufacturing history. Ford demonstrated that complex products could be mass-produced using systematic processes and trained labor, rather than relying on craftsman expertise. This transformed manufacturing from an art to a science. More importantly, Willow Run proved that industrial capacity is not a fixed asset but a variable that can be created through systematic organization and will. The United States went from producing 6,000 aircraft annually to 96,000 in 4 years. This wasn't incremental improvement. This was fundamental restructuring of what was considered possible. The lesson has relevance beyond wartime. It suggests that perceived limitations on production capacity often reflect organizational thinking rather than physical reality. Industries that claim they cannot expand production quickly may simply lack the willingness to challenge conventional approaches. The workers who built bombers at Willow Run carried the experience into decades of peacetime achievement. The skills they learned, the confidence they gained, and the proof that ordinary people could accomplish extraordinary things shaped American society in ways that extended far beyond factory floors. Roswell Monroe, the Riveter who became Rosie the Riveter, used her wartime earnings to purchase a small aircraft and start a construction business. She built houses across Kentucky for 40 years, employing the systematic approaches she'd learned at Willow Run. When interviewed in 1995, she said, "Willow Run taught me that I could do anything if I learned the system and practiced. Before the war, I thought construction was men's work requiring strength I didn't have. At Willow Run, I learned that systems matter more than strength. I built bombers. After that, building houses seemed easy. Margaret Davis, the teacher who installed control cables, returned to education after the war, but with transformed perspective. She taught industrial arts rather than elementary school, training young people in systematic problem-solving and technical skills. Her students, interviewed decades later, remembered her saying, "I helped build 3,000 bombers without being an engineer. You can accomplish anything if you break complex problems into manageable steps and master each step." Systematically, the 6,000 African American workers who found skilled positions at Willow Run gained experience that opened opportunities in post-war industry. While racial discrimination remained endemic through the 1950s and 1960s, workers with wartime industrial credentials found doors open that would have remained closed otherwise. James Bradley, who worked as a hydraulic systems installer at Willow Run from 1943 to 1945, used his experience to secure a position at Chrysler's Detroit assembly plant in 1947. He worked there for 38 years, retiring as a line supervisor in 1985. His oral history, recorded by the Detroit Historical Society, captured the long-term impact. "Willow Run changed my life completely. Before the war, I was a janitor. That's all black men could get in Detroit. Willow Run needed workers and didn't care about color. They trained me. They paid me, same as white workers doing the same job. That was radical in 1943. After the war, I had skills and a work record. Chrysler hired me because I had Willow Run experience. I raised 4 children on assembly line wages. All 4 went to college. My daughter is a mechanical engineer. That happened because Willow Run gave me a chance in 1943. The strategic lessons that military planners drew from Willow Run influenced American defense policy for decades. The understanding that industrial capacity could be expanded rapidly shaped Cold War planning and resource allocation. The U.S. Air Force maintained detailed plans for rapid expansion of aircraft production throughout the Cold War. These plans, developed in the 1950s and refined through the 1980s, assumed that in the event of major war, civilian automobile factories could be converted to military production within months, using approaches demonstrated at Willow Run. This planning was never tested. The Cold War remained cold, but the assumption that America could outproduce any opponent influenced strategic thinking and arguably contributed to deterrence. Soviet planners understood that starting a conventional war with America meant fighting an opponent who could scale production to levels that made victory through attrition impossible. The space program borrowed organizational principles directly from Willow Run. NASA's Apollo program used systematic subdivision of complex problems, parallel production of components, and moving assembly approaches that echoed Ford's bomber factory. The Apollo spacecraft were built using prefabrication techniques and modular assembly. Gene Kranz, NASA flight director for Apollo missions, made the connection explicit in his 1999 memoir. "We built spacecraft the way Ford built bombers. We broke the problem into manageable pieces. We built components in parallel. We used systematic processes rather than relying on individual genius." The Saturn V rocket was manufactured using assembly line principles. We didn't invent this approach. We learned it from Willow Run and applied it to space exploration. The economic analysis of Willow Run reveals productivity gains that remain impressive by modern standards. In 1942, each B-24 required approximately 380,000 worker hours to complete. By 1944, this had fallen to 110,000 worker hours per aircraft. This 71% reduction in labor per unit occurred while production volume increased by 700%. Traditional economic theory suggested that quality would decline as production scaled. Instead, quality improved as workers gained experience and processes were refined. The learning curve effect, demonstrated at Willow Run, became a fundamental concept in operations management. The principle that unit costs decline predictably as cumulative production increases influenced pricing strategies across industries. Boeing used learning curve analysis, pioneered at Willow Run to price commercial jetliner contracts in the 1960s and 1970s. Japanese automobile manufacturers applied the same principles to achieve cost advantages in the 1980s. Chinese manufacturers used learning curve strategies to dominate electronics production in the 2000s. Professor Kenneth Arrow, Nobel Prize-winning economist, published a groundbreaking 1962 paper that used Willow Run as a primary case study. Arrow's analysis demonstrated mathematically what Ford had proven empirically. Systematic experience creates predictable productivity improvements. The paper influenced economic theory for decades and established that technological progress comes not just from innovation, but from accumulated production experience. Willow Run provided the data that proved the theory. The comparison between Willow Run's achievement and modern manufacturing capabilities provides perspective. The Boeing 737 is manufactured at a rate of approximately 42 aircraft per month. This is 1.4 aircraft per day, a production rate that seems impressive until compared to Willow Run's peak of 12 bombers per day. But modern aircraft are vastly more complex. A Boeing 737 contains approximately 600,000 parts. The relevant comparison is not absolute numbers, but the philosophy. Boeing uses the same fundamental approaches Ford pioneered: moving assembly lines, prefabricated sections built in parallel, systematic subdivision of labor. The principles remain valid, even as products have become exponentially more complex. The automobile industry provides another comparison point. Ford's Rouge plant produced approximately 200,000 automobiles annually in the 1940s. Modern automobile assembly plants produce 400,000 to 500,000 vehicles annually using evolutionary improvements to the same basic principles. Toyota's Georgetown, Kentucky, plant manufactures approximately 550,000 vehicles annually with 10,000 workers. This is 55 vehicles per worker per year. Willow Run produced approximately 0.21 bombers per worker per year at peak efficiency. But bombers were vastly more complex than automobiles. A B-24 contained 1,550,000 parts. A modern Camry contains approximately 30,000 parts. Adjusting for complexity, Willow Run's productivity was roughly comparable to modern automobile manufacturing. The lesson is consistency. The approaches that worked in 1943 still work in 2025. The principles are timeless. Systematic processes, moving assembly, prefabrication, subdivision of labor, continuous flow, these aren't 1940s techniques. They're fundamental manufacturing principles that Ford happened to demonstrate at unprecedented scale. The preservation efforts for Willow Run have created an educational resource. The Yankee Air Museum's preserved section hosts approximately 40,000 visitors annually. School groups tour the facility. Engineering students study the layout. Veterans and their families walk the floor, remembering or imagining the experience. The museum has collected oral histories from surviving workers. As of 2024, only a handful remain alive. The youngest workers from 1945 are now approaching 100 years old. Their recorded memories provide irreplaceable perspective. Dorothy Henner, who worked as an inspector at Willow Run from 1942 to 1945, recorded her oral history in 2003 at age 84. People today don't understand what we did. They see the numbers 8,685 bombers and think it's just statistics. They don't understand what it meant to build that many aircraft in 3 years. I inspected hydraulic systems. Every bomber had miles of hydraulic lines under pressure. If a line failed in flight, men died. I was 21 years old, fresh off a farm, responsible for systems that kept crews alive. That weight never left you, but you learned, you got better. By 1944, I could spot a bad flare fitting by touch. I could identify a pressure leak by sound. Not because I was smart, but because I'd done it thousands of times. That's what Willow Run was. Thousands of people learning one thing thoroughly and doing it repeatedly until it became second nature. Excellence through repetition. That's how ordinary people built extraordinary things. Dorothy Henner died in 2010. Her oral history remains available at the museum. The comparison between traditional aircraft manufacturing and Willow Run's approach reveals a fundamental truth about human capability and organizational systems. Consolidated Aircraft's San Diego plant employed approximately 45,000 workers and produced 2,400 B-24s between 1945. This was considered remarkable achievement. Willow Run, at peak, employed 42,000 workers and produced 8,685 B-24s between 1942 and 1945. Using untrained workers and systematic processes, Ford's facility achieved 3.6 times Consolidated's production with essentially the same workforce size. The difference wasn't worker capability, it was organizational systems. Consolidated built aircraft the way aircraft had always been built. Ford built aircraft the way he had learned to build automobiles. Consolidated's workers were more skilled individually. Ford's workers were more efficient systematically. Consolidated's methods produced beautiful aircraft. Ford's methods produced more aircraft. In war, more matters more than beautiful. This lesson extends far beyond manufacturing. It suggests that human potential is often constrained not by individual capability, but by organizational thinking. Ford's insight was recognizing that complex tasks could be subdivided until each component became simple enough for rapid training. Consolidated saw aircraft manufacturing as a comprehensive skill, requiring years to master. Ford saw it as thousands of simple tasks that could be learned in days. Both approaches worked. One worked faster. The final assessment of Willow Run's achievement requires acknowledging both its triumphs and its costs. The triumph was unprecedented. 8,685 bombers, built in 42 months by workers who had never seen an aircraft before the war. Production rates that experts declared impossible. Quality that matched traditionally built aircraft. Costs that decreased while wages increased. The costs were real. Workers exhausted by repetitive labor. Communities overwhelmed by sudden population increases. Families separated by war and work demands. Social tensions from forced integration. Lives disrupted and sometimes destroyed by the demands of total war production. Margaret Davis, who lost her husband at Anzio and spent 38 months installing control cables, captured the complexity in her 1992 oral history. People ask if I'm proud of my Willow Run service. I say yes, but proud isn't the right word. I did what needed doing. We all did. Was it hard? Yes. Was it worth it? I suppose. We won the war. My children grew up in a free country. But I paid a price. Everyone at Willow Run paid a price. I installed control cables on 3,000 bombers. Each bomber carried a crew of 10 men. That's 30,000 men whose lives depended partly on work I did. Some of those bombers were shot down. Some of those men died. I know that intellectually, but I can't think about it emotionally. If I thought about it, I couldn't have done the work. So you learn to not think. You learn to just do the task. Install the cables, check the tension. Move to the next bomber. Again and again and again. You become a machine yourself. After the war, it took years to become human again. To think about what I was doing rather than just doing it. Willow Run taught me I could accomplish anything. But it also taught me that accomplishment has costs that aren't always visible. Margaret Davis died in 1998. She never visited Willow Run after the war ended. She said the memories were too heavy. The story of Willow Run ultimately stands as testament to human capability operating within systematic organization. The facility didn't succeed because Ford employed exceptional people. It succeeded because Ford created exceptional systems. This distinction matters. If Willow Run's achievement required exceptional individuals, the lesson would be, find exceptional people. Since it required exceptional systems, the lesson is, create exceptional systems. The implications extend to every field where complex challenges seem insurmountable. If the problem can be subdivided into manageable components, if each component can be mastered through practice, if the components can be systematically integrated, then the complex becomes achievable. Willow Run proved this with bombers. The principle applies to spacecraft, to medical procedures, to software development, to any complex endeavor where traditional approaches claim impossibility. The workers who built 8,685 bombers were not superior humans. They were farmers and teachers and store clerks and housewives who learned specific skills and applied them systematically. They proved that human potential, when properly organized and directed, exceeds conventional expectations. That is the enduring legacy carved into history not by the bombers themselves, but by the transformed understanding of what dedicated people can accomplish when freed from the constraints of tradition and empowered by systematic organization. In October 2024, the Yankee Air Museum hosted what they believed might be their last public event, with a Willow Run worker present. Robert Chen, age 99, had worked as a tool crib attendant from September 1944 to June 1945. At 19 years old, he had been too young for the draft and too eager to wait. Speaking to a crowd of 200 people, including his great-grandchildren, Chen provided the final word. I was the youngest worker in my section. The women who built the bombers treated me like a son. They'd been there for years by the time I arrived. They knew every rivet, every seam. I remember one woman, I never learned her name, who riveted the bomb bay doors. She was maybe 50 years old, grey hair, thick glasses. Every bomber that came through, she installed the same 47 rivets. Same pattern, same location, bomber after bomber. One day, I asked her if she got bored doing the same thing repeatedly. She looked at me like I was stupid. Bored, she said. Son, those doors have to hold closed while the bomber flies to Germany. Then they have to open when the bombardier needs them. Then close again for the flight home. If my rivets fail, men die. I'm not bored. I'm responsible. That was Willow Run, 40,000 people who understood that their repetitive tasks mattered. That excellence in small things created excellence in big things. That ordinary work, done extraordinarily well, changed the world. I spent 9 months at Willow Run. I've spent 80 years remembering it. Best 9 months of my life. Not because it was easy or fun, but because it mattered. We built things that ended a war and brought people home. If I could tell young people one thing, it would be this. You are capable of more than you imagine. Not because you're special, but because dedication and systematic effort make anyone capable of extraordinary things. Willow Run proved it. 40,000 ordinary people built 8,685 bombers and changed history. Remember that when someone tells you something is impossible, Robert Chen died 3 weeks later. On November 3, 2024, his obituary mentioned his Willow Run service prominently. He was buried with a small piece of aluminum from a B-24 bomber, salvaged from the museum's collection, placed in his coffin at his request. The last worker who built the bombers that helped win World War II had returned to the earth, but the lessons remained. The proof endured. The challenge echoed across generations. Impossible is just a problem nobody has solved correctly yet. Given dedication, systematic organization, and refusal to accept traditional limitations, ordinary people can accomplish the extraordinary. Willow Run proved it in 8,685 bombers built in 42 months by workers who learned their skills in weeks. The mathematics of that achievement speak louder than any expert's declaration of impossibility. The legacy lives in every modern factory, every systematic process,